The sum of an arithmetic series will involve possibly two formulas. The more complicated formula is given to you in the exam paper. So it's this one here. So the sum of a series is S of n is equal to n over 2 bracket 2a plus n minus 1d, close bracket. And here n is the number of terms, a is the first term, and d is the common difference. The other one you need to memorize, which is just finding the nth term. They can be found in many ways, but this is the simplest way. To find the nth term is a plus n minus 1d. So that's your first term plus n minus 1 times the common difference. That's one you would have to learn. This is one you just have to be able to use. In this question, you've got the sum of the first 48 terms of an arithmetic series is 4 times the sum of the first 36 terms of the same series. Find the sum of the first 30 terms of this series. A lot of words, let's try and break that down into something a bit more manageable. The first bit, the sum of the first 48 terms is 4 times the sum of the first 36. So, sum of 48 is equal to 4 times the sum of 36. And we're trying to find the sum of the first 30. So S of 30. Now our formula is at the bottom here. Let's put this in. Let's try and do something with this. So sum of 48. So we know that S of 48 is going to be 48 over 2. That's our n, remember, over 42. Multiplied by 2a, I don't know what a is, plus 48 minus 1, multiplied by d, which is my common difference. I don't know what that is. Now I know that is equal to 4 multiplied by the sum of 36 terms. So it's 36, which is my n in this case, over 2, multiplied by 2a, still don't know what that is, plus 36 minus 1 times by d, still don't know what that is. But the a and d are the same for both of sides of the equation. Let's kind of tidy this up a bit. What have I got here? I've got 24, 2a plus 47d equals 4 divided by 2 is 2, 2 is 36 is a 72, 72, 2a plus 35d. Now a quick inspection would see that 24 is a factor of 72, so I can divide by 24. So I'm left on the left-hand side here with 2a plus 47d equals 3 2a plus 35d. Let's expand that bracket out. So I've got 2a plus 47d, leave that alone. 6a plus 105d. And let's tidy this up completely, make it equal to 0. Take 2a away from both sides, I've got 4a. Take 47d away from both sides. And that gives me 58d. And although both even, so let's just divide by 2. So I've got 2a plus 29d. That looks pretty horrible, but let's just stop there. And let's just focus on the sum to 30. So our sum to 30, we have... what do we have? We have n, which is 30, 30 over 2, multiplied by 2a, still don't know what that is, plus n, which is 30 minus 1, multiplied by d, and I still don't know what that is. Let's tidy this up now. We have 15, 2a plus 29d, and, oh, look at that, 2a plus 29d. I have that here. The a and d are the same values because this is all one series. And 2a plus 29d is equal to 0. So I can just substitute that straight in. They have the same value. So that's 15 multiplied by 0. Well, that's going to be equal to 0. So the sum to 30 is just equal to nothing. So from what is a really horrible looking question, it actually works out quite nicely. Too nicely, in fact, really. Probably worth double checking the algebra just in case there's an error there. But it looks good. It looks that this will just substitute straight in, and we're done. The second question here involves the nth term formula as well as the arithmetic series. Remember this one at the bottom right you are not given, you have to recall it or derive it during the exam. Okay, so what we have here is we have the third term of a series A is 19, the sum of the first 10 is 290, and we want to find the 10th. Let's write a couple of equations. So it says that the third term is 9. So third term will be, so it's 19. So 19 equals A, which is my first term, plus n minus 1 times d. N is obviously 3 in this case, so 19 equals A plus 3 minus 1d. So 19 is equal to A plus 2d. And let's just call that equation number 1. Now let's do the sum for the first 10. So I know that sum of 10 is 290. So I've got 290 is equal to n over 2. So that's 10 over 2 multiplied by 2a. I don't know what that is. Plus n minus 1. So 10 minus 1 multiplied by d. Let's tidy this up. So 290 is equal to 5, 2a plus 9d. We can divide by 5 to make that a bit nicer. So 58 is equal to 2a plus 9d. And I'm going to stop there and call that equation number 2. Comparing my two equations that I've numbered, I can do simultaneous equations and solve these. And in fact, I can look at equation 1. And I can take equation 1, I can multiply it by 2. That's going to give me 38 equals 2a plus 4d. So that's now equation number 3. I'm going to label them as I go, so it's very clear to the examiner what I'm doing. And now if I inspect these two, I can subtract equation 3 away from equation 2, because my a terms will then disappear. So let's tell the examiner what I'm doing. I'm doing equation 2, subtract equation 3. So I do 58 take away 38, that's going to be 20. And I got 2a take away 2a, well that's nothing. And 9d take away 4d is 5d. This is looking good. So d must equal 20 divided by 5d is equal to 4. So I know my common difference. Now I can substitute that value into any of my equations. The easiest one is probably equation 1. So sub into 1, I have 19 equals a plus 2d, so it's 2 times 4. So 19 is a plus 8, so a equals 11. I have my a, I have my d, and now I should be able to find my 10th term. So my 10th term is going to be equal to a, which is 11, plus n, which is 10, minus 1, multiplied by d, which is 4. So it's 11 plus 9 times 4. 11 plus 36, so the 10th term will be 47. So this is a more typical question where you're forming simultaneous equations, and then it is a matter of being able to solve simultaneous equations to work your way through.